Welcome everybody to the first video on my channel. In this video, I'm going to go over how to draw organic molecules and read their bonds. So, have you ever looked at these weird zigzags? Just thought, where are the atoms? There's supposed to be atoms there. Where are they? Doesn't say. Well, I'm going to be telling you guys how we find where the atoms are in one of those and how to draw our very own. So, welcome back to the very first video. Hoping this finds the right audience and helps people out a lot. So we're going to talk about how to draw organic molecules and how to read their bonding. They're the bondings in them. Shouldn't be too difficult. We'll start with the basic type of drawings you'll see mainly in classrooms. Then I'll show you a simple method to check that every atom has the right number of bonds. So just grab pen and paper and follow along. Alright, so first there are three very common ways to draw organic molecules. First, the Lewis dot diagram. The main one you're going to be seeing a lot. Start with just a simple one, carbon and hydrogen. Lewis dot diagram. Simple, easy, not too difficult whatsoever to draw. Next, we're going to move on to a condensed formula. This is basically the same information as what I just showed you. It gives you basically the same information, but the first method, like the Lewis full structure formula, which is what it's called, that one gets really, well, it's good for beginners, but gets very messy for bigger molecules. So that's when we start going on to the condensed formula. Same information, but hydrogen bonds to carbon are squished into groups. So an example would be ethane. Ethane is written as CH3 to CH3. Still fairly simple. Hopefully you guys can still see it, but not difficult. It's going to get a little bit more difficult as we go on, but there you go. There's a condensed formula. It's just telling you where the bonds are going to be. So I'll go a little more in depth. So on this carbon, there is going to be 3 hydrogens, and all of this is going to be connected to this one, which is going to be the exact same thing. Carbon, 3 hydrogens connected to our carbon. Simple, easy. So, I always butcher this pronunciation, but skeletal bond line formula, which, as I showed as the start, is one of these guys. These weird lines. So I won't go in depth on the extra root, but on each one of these corners, there's going to be 1 carbon. Just like that. So each one of these dots that I just drew is a carbon bonded together. So in this one, we would have C4 due to us having 4 carbons. Still not too difficult. Those are the 3 main types I'm going to be going over. We don't have to draw the hydrogens attached to it, because there would be hydrogens attached to that one, but we're not going to draw those. Because you don't need to draw when you're drawing one of those. So, here's a simple 4 carbon chain. So, first of all, we're going to start with our 4 carbon chain on our Lewis dot diagram. It's going to have carbon to carbon to carbon to carbon, with a hydrogen heading out on every single one. And this is why I say there's better ways to draw it, because after a while it gets pretty messy and takes a while to draw. But yeah, this is just our Lewis dot of a 4-carbon chain. So that's a simple 4-carbon chain. So now for the condensed. The condensed of the 4-carbon chain is going to be CH3 to CH2 to CH2 to CH3. Just showing us what's going to be combined to each carbon atom. Still, not difficult, right? Now it's time for the skeletal. It's honestly the easiest one. So, since we have 4, we're going to go 1, 2. 1, 2, 3, 4. Every corner is a point. Same thing. But there are no need in drawing all the hydrogens. Right? Same thing. 4-carbon bond. 3 different ways to write it. Alright. Bonding rules that you might want to memorize. Honestly, must memorize, in my opinion. So before I go any further, you need a few simple bonding rules. These tell you how many bonds each common atom wants in organic molecules. So carbon, which is just C, is always going to want 4 bonds total. Hydrogen, which is H, is going to just want 1 bond. Oxygen, which is O, is usually 2 bonds. Nitrogen, which is N, is usually 3. Just 3 bonds. Halogen, which our halogens are fluorine, chlorine, bromine, and iodine. They're usually going to be just 1 bond. So a bond, you're going to hear me say that a lot. A bond is just the connection of electrons between 2 elements, or sharing of electrons between 2 elements. There are 3 main types of bonds. There's single bond, which is just 1 bond, double bond, which is 2 bonds, and triple bond, which is just 3 bonds. So carbon and a double bond plus 2 single bonds still has 4 total bonds. It's just the double bond, which is 2, plus the 2 single bonds on it, which I'll show you actually how that's supposed to be drawn. That would be a carbon with a double bond to a carbon with a carbon on a carbon. Same thing, just there's a double bond in it. The 2 lines means there are 2 bonds to it, right? Not too difficult. Still, not difficult. So, yeah. In ethane, the 2 carbons are double bonded to each other, and each carbon has 2 hydrogens. Kind of simple. So, I'll go a little bit more in depth in ethane a little bit here, but just for you to contemplate, each C or carbon has 1 double bond, counts as 2 bonds, plus 2 single bonds, plus 2 more, which is equal to 4 bonds. Right. Alright. So, how to draw simple organic molecules. So, we're going to draw a few molecules step by step and identify their bonds. I'm going to go over 3 examples. First example that I'm going to go over is propane. Propane, which is an alkaline, which means only single bonds. So alkaline is going to mean only single bonds, which is why propane has its name of propane. It's got ANE, same with alkaline, ANE. It just means single bonds throughout the whole thing. So first of all, we're going to do, how do I want to do this? So first of all, we're going to start drawing it as a Lewis dot. So we're going to have our 3 carbons, because as I said, it's C3H8. Oh, I didn't say that, but it's C3H8. That's the amount in each. So Fairly simple. Our 3 carbons with our 8 hydrogens all around. Still simple. Right? Simple. Like I said before, they can get real messy real fast. Our condensed still are 3. So it's going to be C3, C2, oh, whoops, to C3. Yeah? Still with me? Simple. Move on. We're still doing propane, but we're going to now do the, give me like 1 second here. Now we're going to do the skeletal version, right? So, as I said before, propane is the 3 carbons. So it's just our 3 carbons connected. And there you go. Done. Propane. Just like that. Simple, easy. Why we decide we're going to just put it into that form. So, now, since that's all drawn, we are going to move to example 2. Example 2 is propene, which sounds funky, yes I know. It ends in ene, which means it has a double bond, which is 2 bonds between the carbons. So let's draw it. We're going to start by drawing it as our Lewis dot. Okay? Lewis dot. Simple, right? Carbon, carbon, carbon. We're going to have a double bond between our first carbon and a single bond on our next carbon. Just because it says it has a double bond doesn't mean all of them are going to be double bonded. So, how this one is written, propene, since it has a double bond, it has less hydrogen, so it's actually H6. So, as I said before, carbons are going to want to make 4 bonds. We have 2 bonds between the carbons. So therefore, this carbon already has 2 bonds, therefore just needing 2 more to complete what it wants. This one, it's got 3 on it, because this one counts as a carbon as well. Or, not carbon, a bond. So we have 2 carbon to 1 bond to 2 bond. So we only need 1 more hydrogen bond in the center, and then this one needs all of its hydrogen back again. Since it needs its 4 bonds. There you go. Lewis dot of propene. I'm not going to go on to the condensed version of it because I mainly don't remember how to write that one. But now we are going to move to the skeletal form. So, like I said before, it's our C3, right? So, 1, 2, 3, right? Carbon 3. How we show a double bond in this formula is we just put a second line. There you go, double bond. Still really easy. So, that's that form. Now, we're going to move on to example number 3. Now we are going to move on to ethanol, which ethanol, if you don't know, is C2H6O. That's what it is. So 2 carbons, 6 hydrogens, 1 oxygen. So now we're going to draw just molecule with oxygen. Not much more difficult. If you must know, ethanol is mainly found in, well, it is the alcohol in drinks and also found in most fuel. So ethanol in gas and sometimes diesel. So first of all, we're going to draw, like we always start is our 2 carbons. We're going to start with our carbons, carbon to carbon. Then, since we have an oxygen, we want to get the oxygen to then be connected next, right afterwards. So, see, we're going to connect an oxygen to it. But if you draw it the rest of the way out, we have hydrogen here, hydrogen here, hydrogen here, hydrogen here, hydrogen here, but we're missing hydrogen. It's supposed to have 6 hydrogen. Well, remember when I started out the video, I said the main rules that you're going to want to remember. Oxygen always wants to make 2 bonds. Oxygen is missing a bond. That's where our final hydrogen is going to end up. So, not actually adding too much more. So, that's all you're really going to get extra for a just oxygen on it. So, there you go. There's ethanol. So, now we're going to go over how that would look as a skeletal form. Sorry, I keep pronouncing it so bad. So, first of all, it's not difficult. So, we're going to draw a line symbolizing our 2 carbons. And then we're going to put an oxygen attached to this carbon. This is one way of drawing. I'll show you another way in a minute or two here. But, yeah, that's really all it is. If you really want to, you get fancy and put another line there and then a hydrogen, knowing that there's a hydrogen there. But how I draw these is I just draw this. Having this as our breaking point, so this is 1 carbon, this is 2 carbon, and then we have a branch of oxygen coming off of carbon. That's how I draw it. It makes most sense to me to draw it that way, not any other way. So, now, how to read a skeletal structure and find hidden atoms. Still very simple. So we're going to now practice identifying the bonding and skeletal diagram well, I'm not going to draw one. So, first of all, we're going to start with, I'm going to actually draw one. Never mind, I'm lying to you guys. Alright. Anyhow, so every end and every corner is a carbon. Following the line and count. So, following the line, counting, we got 1, 2, 3, 4, 5. We got 5 carbons. So, C5. Right. Still fairly simple. Identify our multiple bonds. So, here, remember as I said earlier, we're going to have 2 lines and in one section to show a double bond. So, we've got a double bond here, so this is going to be sorry if I keep a second. Sorry if I spelt that horribly wrong. This is ENE, by the way. So, probably spelt that absolutely horribly wrong. My bad, guys. But since we have our double bond, it's going to be an ene. So, this is an ene at the end of our name. So, this is... So, since we have our double bond, we have C5. This is going to be pretty simple. We have 5. So, if we go to octagons and stuff like that, if you have a 5-sided, whatever those are called, I forget what they're called, but if you have a 5-sided one of those, the name is pentagon. Am I correct? So, how that works is pent means 5 in that case. In the same case as this, since we have 5 chlorine, or not chlorine, carbon, this is going to be pent. So, pent as in 5. So this is pent, and since we have a double bond, it's ene. So we got pentene right here, right? Still, not difficult. So, yeah. Not difficult. Very simple. Just count out how many carbons you have. If you have double bonds, identify those. If you have any external branches, like I didn't do it, but there could have been oxygen there. There could have been multiple elements like a chlorine or maybe even a bromine. There could have been many elements there, but there wasn't. So just remember, if you have one of those, make sure you say that in the name. Might get the name to be a little bit longer, but that's fine. So, yeah, all you gotta do, just remembering simple steps, count carbons. Yeah, so just simple. Just a quick final checklist for you guys if you're wanting to make your own organic structures and name them. Just remember, for each carbon, count all bonds, so single, double, triple. Remember, every carbon must have up to 4. For each hydrogen, check if there's only 1 bond. Oxygen, make sure there's only 2. Nitrogen, there are 3. Halogens, there are 1. And skeletal drawings. Remember, corners and ends are carbons. Hydrogens on carbons are just invisible, but hydrogens on other atoms can be drawn. So that's all I've got for you guys on this. If you'd like to know any examples that you'd like for me to go on and just simplify for you guys, let me know in the comments, and I guess I'll see you guys in my next video, which should be my physics assignment. So